What's up, guys? It's been a long time since I recorded a video, and I realized a little bit late that today's project I was working on would have been a great topic for a live stream, but since I didn't start recording early into the project, I figured I would just make a video and kind of show off what I was doing today, and hopefully leave you guys with a couple of interesting tips that you can go play with on your own in Rust. So, I guess, first of all, I'll just show you guys what I built today. And the idea here is to have a small application that I can enter my weight into. Now, I don't know why any of you would know this. I was going to say some of you might know this, but I don't know any of you who would know this except for Zach, basically. But one of my hobbies, if you can call it that, outside of doing computer stuff like I usually do on the channel, is lifting weights. So with that comes, for a while I didn't really worry about my weight too much, but I think last fall I started trying to do some like cuts and bulks. I'm in the middle of a bulk right now, so I'm up to around 225. But anyway, the point of all of that is just to say that I've been tracking my body weight basically every day for like 6 months. And I've just been doing that on paper. So I have a notebook downstairs that I weigh in every morning and I log it on paper. But I would really like to take that data and do things like compute my median weight for a week or my average weight for the week, or just see the weight graphically over time. And I've been kind of lazy about doing that. I was like, I really don't want to have to like remember the weight and come upstairs, like type it into my computer. So earlier today I was like, man, it would be nice if I could have like a phone app, except I have an iPhone and I don't have a Mac, so it's like impossible for me to develop an app. And then I was like, oh, duh, I can just have a very simple web app that I can log into from my phone, or just connect to, not log in, and punch in the weights like that. So that's what you're seeing right here. I'm calling it Weight Watcher, which is probably, hopefully I don't get like sued by Weight Watchers, but I doubt that they're looking on GitHub for open source projects. Anyway, what I want to show you today is just a very simple web application I built today. I was trying to do it with no dependencies. I ended up having to take one dependency on the time crate because apparently it's, I guess I'm not going to say impossible, but very difficult to compute like the day of the month, like you're seeing over here, the date, using just the Rust standard library. So I did take a dependency on that, but I'm not using any web frameworks like Axum or ActixWeb, which are the two I have some experience with. I really like them both, but you know they definitely add a bunch of dependencies, and I was going for something simple, easy to compile today. I also don't have a dependency on a templating library like Ascama, which is what I usually use. I guess I can pull these up. Thank you, Firefox. So this is what I usually use. These are Jinja-like templates, if you're familiar with Jinja from Python. And it's pretty cool. Like you annotate a struct with this derived template thing, and then you have an HTML file, and it all happens at compile time. So Ascama is really cool. And I've also built projects with both Axum, so that's AXUM, Rust, and with ActixWeb, Rust. So I've used both of these as like serving stuff. You'll see that they both use async, so I'm also managing to avoid async today with my simple server. But I can recommend either one of these, and also Ascama. I've used all of that for the larger web projects I've worked on. So what you can see here is we've got this simple little weight entry. Let's do 227. Probably hit that next week at some point. I can hit enter, and you'll see that it should have been added to this, but apparently it disappeared. 228. Okay, I must have modified the file outside of this before, something like that. But anyway, you'll see that we can punch in a weight here, we hit submit. It gets added to this table of recent weights. If we add enough of them, you'll see that eventually they disappear because I'm only printing the top 7. So basically this table is for viewing your last 7 weights. I think that's 7, so let's see, 2, 3, 2 should push the bottom one off the edge. There we go. And you'll see down at the bottom, obviously I am including a graph of the last month of weights, and I'm using NuPlot here. So with all of that demoed, let's go and take a look at the web server itself. So we can kind of ignore a lot of this stuff up at the top. This is just me parsing the home environment variable, joining it with the .config directory, and then I like create a new directory if it doesn't exist with the name of the program. I guess we're not ignoring this section, but then I just join it to this file I'm calling weights.dat, open the file with the read and append options. If you haven't seen this file options thing before, it's pretty handy if you don't just like want to truncate the file and write over it. And then let's see, I load the current list of dates and weights into the into a vector, and then I create this like state app. And then the really interesting part is we just start listening to a TCP connection, or I guess a TCP socket, right? We use TCP listener, and when I first started out, I was using like 127.0.0.1 to listen on localhost, but I switched this to 0.0.0.0 so that I could connect to it on my phone. And that's really all we do. That's that's how we bind to the port. I just picked 9999, basically randomly, and then all you do down here is you say for stream and listener.incoming. I have a dispatch function that takes this stream, which I've unwrapped here. So you'll see that this is a TCP stream. I pass that TCP stream off to my dispatch function, along with a mutable reference to my state, and we go to town. So let's go take a quick look at dispatch. This looks a little bit messy, I would say, but overall it's pretty simple. This section of code is basically straight from the Rust book. There is a chapter towards the end of the book, which is a project on implementing a web, like a chat server, I think. And so this is the first thing they have in there. You just take first you wrap the stream in a buff reader so that you can call lines on it, and then you just take while the line is not empty. And the reason for this is because in the HTTP specification, the end of the request is marked by a blank line. So we basically just collect everything at the top of this. I assert that the request is not empty, so we just got at least one line. And then you'll see that I only look at the first line of the request. So this is a line that looks something like HTTP 1.1 get, or wait, you put the get, I think you put the URL and then get, something like that. So I assert that the length is 3 because it's supposed to look something like this. And yeah, then I take the URL, which is in the first field. So this is not a very complete HTTP server, but it is an HTTP server. So we simply look for the URL in the request. And then I also split the request looking for like query parameters, which you'll see why in just a second. And again, I'm just doing some checking on what's in there. And then this is where I put all of my handlers. This is what really makes the function called dispatch. So this is where I look at the handlers, or I look at the URL, and I dispatch to different functions based on the contents of the URL. So you'll see if I get this just a slash, I dispatch to my index function, which is right down here. It has this thing called like state update. So this basically refreshes that table that we saw earlier. And then it does some template expansion, which we can see if I just open this file, index.html. I do this kind of like Jinja or Escama style syntax where I put things I want to replace in these double curly braces, but then the only way I replace them is just with string replace. So that's basically just an HTML file that I do some replacements on. And then we can take a look at this graph function, which this is where some of the time stuff comes into play, where I like compute the current time. This is how I actually get my date range for the plot, if you guys notice that. I compute like now minus 28 days and then now plus 1 day. That gives me a little bit of padding on the right side of the graph. We do the same kind of template expansion in our new plot script. It looks like this. And then we just pipe that into the new plot command. I pass it standard in. This is all pretty much from the example usage of command spawn as well. So again, I got to see some really, really good Rust documentation today. So that's how I'm building the graph. Let's jump back a little bit. And you'll see that I actually generated this like response type struct. This is not good. If you've used, as I was saying before, Axum or Actix, they come with like much more, I'll just say intelligent types for this kind of thing. But I just wrapped some of this functionality up into this struct. So we have a status. So this is stuff like 200 for successful, which you can see down here. Okay, just gives you a 200 right away. A redirect, which I use, we'll see why in a second, 303, and then error is just 404. So not very sophisticated error handling or anything like that. But this is enough to get you started actually serving HTTP requests. We've also got location. This is only used for the redirect, so really that should be probably coupled with this status thing. And then we've got a content type, even though I've only got like 2 content types, HTML and PNG. And then we've got this body thing, which is itself an enum. Originally it was just a string, but when I wanted to start serving PNGs, I needed a way to embed them as bytes instead of trying to read the PNG file into a string, which I believe would not work because all of the bytes in a string have to be valid UTF-8, and I don't think that that is going to be the case for random U8s in a PNG file. Obviously they're not random, but effectively random. So with this response struct, I try to do kind of the builder pattern. It's not really necessary here, but it's kind of nice when you have some fields that you want to leave default. So like just calling OK, redirect, and error give you pretty reasonable defaults. So you can use this builder pattern to add things later on, like add a body, add a content type, and so on. And this just translates self.status into the reason. And we can see why down here. So I'm using just an impl display for the response to turn it into an HTTP response that I send back on the, what's it called? On the stream. Yeah, so you can like write it back to the TCP stream. This is what I'm writing back. So if location, we write a location. Otherwise, we write content type. And this is like the end, as I was saying earlier, where you just send a new line, which is like the end of the thing. We write our status, our reason, and so on. So this was a pretty fun little project just to get a little bit of familiarity with how, I guess not really how TCP works, but a little bit of familiarity with how simple HTTP is. If you just use these like web frameworks, you don't really know like how much or how little is going on below the surface. So who knew that you could just like parse the first line of an HTTP request and send back such a simple little struct, basically send back such a simple string, and you can get like a full web page working. So we talked about this index route. Here's our wait route. So you'll see I'm using this, I think they call this some kind of like match guard or something. If parts.length is 2, so parts again is this part where I'm splitting the URL and the query parameters. So this is basically saying if I have query parameters, then I call my wait handler. We'll go look at that in a second. But before we do that, we can just talk about this favicon thing. So this is the little, get ready for the white background. The favicon, of course, is this little, if that's how maybe people pronounce it like fave icon, I'm not sure. I always say favicon. But that's this little scale I made earlier for that. So this is one of the places I'm using the PNG content type. So you'll see we got response OK, content type PNG, and we include these bytes from a file. One note on using include bytes and include stir. This is actually slightly annoying when you're actually working on these HTML files, because these macros include those things at compile time. So if I go and tweak this HTML file, I actually have to recompile the server to fix the string in the binary. But the nice thing about doing it this way is that when I compile the binary, I can move it around, and it's not going to have a dependency on where these HTML files exist on the file system at runtime. So that's the reason I did it this way. I think one thing it would be nice to do is probably define another macro that inside of it has something like config, I forget what it's called, is it debug or something like that, where when you build it in debug mode, it pulls, it uses like read to string so that it pulls it in at runtime, but when you're in release mode, it embeds the actual strings. So it'd be nice to do that, but I haven't done it yet. And then this is how I serve the the file we write to the temp directory. So this is probably the one thing that makes the code not particularly portable, because I think some operating systems probably handle the temp directory a little differently, and I've hard-coded where we put this PNG. But everything else I think I've made pretty generic. And you'll see again, yeah, we're serving the PNG when you ask for it. Is that pretty much it? So that's, I think, oh, we still have to go down into the wait handler, and then we've pretty much seen the whole project that I worked on today. So you'll see in wait, we're just splitting apart our query parameters, returning these error pages if we don't find what we're looking for. I actually don't check that the left-hand side of the equal sign is what it's supposed to be, which is a W in this case. But again, this is like a toy project, and it's going to do exactly what I want. There's not going to be like malicious input or anything like that. So I just stuck with simplicity for now. You can see this is where we're actually using the time library. We're doing this offset date time, now local. So this gives me a date and time in my time zone. And then I have this simple format date function that just pulls out year, month, day. There is a feature flag you can turn on for date formatting, I think, in the time crate, but I didn't do that. I just went with this this simple string formatting technique. So when you hit the wait endpoint with the proper query, I just write this to the end of the file that's held in our state struct. We put the date and the wait formatted with 1 decimal place, and then I also push this onto state.data. And then this is where the redirect handler comes into play. So again, if we do redirect, you'll see this is going to give us status 303. It takes this to argument, which just tells it the location to redirect to. We've got this empty body and content type. So that's pretty cool. So there's our state struct. And again, well, not again. I told one of my Git commits this earlier, but I haven't told you guys yet. This appending to the data is kind of not that important, because if we go down and look at my if we go look at the index handler, you'll see that I always call state update before I call state HTML table. So in reality, I could just load these and not actually hold them in state, but again, it's no big deal. Originally, I was using the data in the state that gets read in at application startup, but then I noticed that the graph was getting more up to date. If you ever go and edit the file, the underlying actual file, the the data was getting more up to date than the graph was getting up to date, and the table was not. So I had to go back and add that. But anyway, that's pretty much it. I'm gonna put this on GitHub under the name Weight Watcher, and you guys can go and check it out. Let me know what you think. And go out and play with TCP and HTTP on your own. This is pretty sweet. So, as always, thank you guys for watching, and I will see you next time.